In this video, we'll be looking at ratios and proportions. We'll also be focusing on how these two things can be used within geometry. Alright, so first of all, let's talk about a ratio. What exactly is a ratio? Well, a ratio is a comparison between two quantities using division. That sounds like a fancy definition. Let's break it down a little bit. Let's say in a class we have 20 girls and 10 boys. Normally, so if there are 20 girls and 10 boys, you would say that the ratio of girls to boys, you could say that the ratio of girls to boys is 20 to 10. And notice we use a colon instead of the word to, or we could say 20 to 10. Alright, but normally when you see a ratio, it is actually reduced as far as possible, meaning if there are any common factors between these two numbers, we want to divide by that common factor, the greatest common factor. So in this case, the greatest common factor of 20 and 10 is 5, so we can go ahead and divide by, that's not true, the greatest common factor of 20 and 10 is 10, so we can go ahead and divide both things by 10, and we get that the ratio of boys to girls is actually 2 to 1. So this gives us a picture of the room, like, okay, for every one girl you see, there are 2 boys. And so that's the point, and that's the purpose of a ratio. So it's really helpful to be able to reduce that number and see the comparison. Okay, so a ratio could be written, as I said, it could be written as with a colon, or you could have written 2 to 1, or you could have written it as a fraction, so 2 over 1. My personal favorite is this, but it's not saying it's the best way, it's just the one I like the most. Okay, so we just compared two things using a ratio, but a ratio can actually compare more than two things. So we can have an extended ratio comparing 3 or more things, as many things as you actually want. So let's say we are in a pet store and there are only fish, cat, and dogs in this pet store for some strange reason. Alright, so if I said to you that the ratio of dogs, hold on, alright, so dogs to cats to fish is 2 to 3, that's my weak attempt at a colon, to, let's say, 10, that means, well, for every 2 dogs, there are 3 cats and 10 fish. So that doesn't mean that there are only 2 dogs, 3 cats, and 10 fish. It just means that it can be reduced. Perhaps there are, in this fish store, in this pet store, perhaps there are, 4 dogs, 6 cats, and 20 fish. So I just doubled everything, but, we could have tripled everything, we could have quadrupled everything. All we know is basically what it breaks down to when we see this simplified ratio. Alright, now let's take a look at how this can affect geometry. Let's look at a couple examples and work with some ratios here. Okay, so here we have an example, and in our example, we're being asked to find the measures of the angles of a triangle. And we do know that the ratio of these angles, the measures, is 3 to 4 to 5. And of course it makes sense that there are 3 parts here because, of course, every triangle has 3 angles. So, alright, we know that the measure is 3 to 4 to 5. So we also know something else about the angles of a triangle. So the sum of the angles in a triangle should always be equal to 180. But clearly if you add these 3 things up, we don't get 180. What's the reason for that? Well, the reason for that is because, this is the reduced ratio. There is another version of this ratio with the actual angles. So when you add the actual angles up, you will get 180, but that has to be the unreduced angles. Alright, the unreduced ratio. Alright, so how do we get this unreduced ratio? Well, we know that when we reduce something, we're multiplying by the same common factor throughout. So this, and this is a result of dividing by some common number. So in order to figure out what that common number is, we can go backwards and we can say, okay, these 3 was multiplied by some number, so was 4, and so was 5. Let's call that some number. That number is x for now. Alright, so when we have 3x plus 4x plus 5x, that would have been the unreduced ratio. And when we add those things up, we should get 180 degrees. So now we should go ahead, solve for x, and that would help us to figure out the measures of our triangle. So let's do that. All right, so we have 3x plus 4x plus 5x gives us in all 12x, and that is 180 degrees. Now we want to isolate our x, so we can go ahead and divide both sides by 12, so we can get rid of that there. And we get that x is equal to 15. However, that is not the answer, because that's not what the question is asking for. The question is asking for the measures of the angles. Well, remember that the measures of our angles are 3x, 4x, and 5x, which means that, well, 3x we know is 3 times 15, because now we know that x is 15. So one of the measures is 3 times 15, which is 45. Another measure is 4 times 15, which is 60. And the final measure is 5 times 15, which is, what is that? 75. Okay, so let's take this a step further and start to look at proportions. Okay, so what's the difference between a proportion and a ratio? Well, a proportion uses ratios. A proportion is an equation that states that two ratios are equal to each other. So proportions are super duper useful, not just in geometry, in real life. Proportions happen everywhere. Proportions happen in medicine, in architecture, everywhere. So we need to have proportions down packed. All right, but let's just take a look at a basic proportion now and how it works. Let's say we have two ratios, and we have that 6 to x is equal to 21 to 31.5. How do we solve for x? How do we figure out what x is supposed to be? Well, whenever we have two fractions or two ratios equal to each other, we can always cross multiply. That's worthy of noting. So you might want to write that down. Again, anytime you have two fractions, so we have two fractions here, or two ratios, and they're equal to each other, you want to cross multiply. All right. So how does one cross multiply? So visual makes it super easy. It's literally a cross, and we literally multiply. All right. So we're going to multiply the top and left, top right, and actually, it's easier if you just see it. Okay. Top right, bottom left. We multiply those two things. So we get 21 times x. All right. Top left, bottom right. We multiply those two things also. When you do those two things, the results will be equal to each other. So what we get from that setup is that 21x, which we got by doing this, is equal to 31.5 times 6. All right. Once we have that down, the rest is not so bad. We rewrite this 21x because we don't know what x is. We simplify this because we can simply plug that into our calculator or do it in our heads. And we get that 31.5 times 6 is equal to 189. So again, we're trying to solve for x. So we can go ahead and divide both sides by 21. So we can get rid of that on that side. And we get that x is equal to 9. And so that's how you work with a proportion. Now let's take a look at how a proportion could show up in geometry. Okay, so this example is actually pretty similar to the example we did with the triangle, but this time we're going to use proportions to solve. You can use whichever way you prefer, but I would like you to see the proportions way. It's actually my preference. Okay, so let's go ahead and do this. So we know that the ratio of the sides is, the side lengths is 2 to 3 to 5 to 4. And this is a reduced ratio. So let's say the ratio was not reduced. If the ratio was not reduced, that would mean that the side lengths are 2, 3, 5, and 4. which would mean the perimeter would have been 14. But we know that the perimeter is not 14, the perimeter is 154. And the reason the perimeter is bigger is because this ratio was reduced. All right, so when you do have a situation like this, we right now have a ratio, and our ratio has a sum. So this is our ratio right here. Right here's a ratio. That's the sum of our ratio. We also have, but we just don't know it yet, we have actual values, and we have an actual sum. And our actual sum is 154. Okay, so we are being asked in this question to find the shortest side, so the side related to that too. We can set up a ratio where we're putting part over whole, and that will be equal to part over whole. What do I mean by this, you are asking yourself? I will tell you right now. All right, so the ratio part over whole is just a reduced version of the actual part over whole, which means that our part, which is 2, over our whole, which is 14, and that's the ratio part over whole, is going to be equivalent to our actual part, which we don't know, so let's call it x, over our actual whole, which we do know is the perimeter 154. So now we can go ahead and cross multiply to figure out what x is. So remember, cross multiply, you're going like this and this, and we get 154 times 2 on the left side, and on the right side we get 14x. Now 154 times 2 is 308, and that is equal to 14x. And now finally we can divide both sides by 14, and we get, let's write it up at the top because I ran out of space, we get that x is equal to 308 over 14, which means that our shortest side, x, is 22. And so that's how you work with a proportion.